Welcome to Let Us Start Educational Channel. In last class, we discussed that some problems on angle between actors. In this, one problem is remaining. Let us discuss that one. So, the problem is a man walks towards east with certain velocity. A car is traveling along a road which is 30 degrees west of north, while a bus is traveling on another road which is 60 degrees south of west. Find the angle between velocity vector of a man and car, car and bus, bus and man. So the problem given is a man walks towards east. In last classes we discussed that we represent the directions like this. This direction is east. Opposite to east is west. Upward direction is north. Downward direction is south. So the problem given is a man walks towards east. That means he is moving in this direction. This is east. Who is moving here? A person. The person is moving in this direction. Next one is, this east means x-axis. Next one is, a car is traveling along a road which is 30 degrees west of north. This is east. This direction is north. So a car is traveling along a road which is 30 degrees west of north. Car 30 degrees west of north. So here car is making an angle of 30 degrees with the north direction. C for car. Next given is, a bus is traveling on another road which is 60 degrees south of west. 60 degrees south of west. This is west. This is south direction. So bus is traveling on another road which is 60 degrees south of west. South of west. So it is making an angle of 60 degrees. So who is moving in this direction? A bus is moving in this direction. Now find out the angle between velocity vector of, these are all velocity vectors. These are all velocity vector. Here a car is moving in this direction, so it is velocity vector. Here a bus is moving in this direction, it is velocity vector. Man is moving in this direction. So in this direction vector, velocity, find out a man and car. First one is, find the angle between man and car. Man is here. Car is here. So this is x-axis. This is y-axis. How much is the angle from here to there? is moving in this direction. This is y-axis, nothing but north direction, and a car is making an angle of 30 degrees with y-axis. So this is degrees. So this is man, this is car. Find out the angle between man and car. How much is it? X and y axis, these two are perpendicular to each other. So the angle from here to here is 90 degrees. So the total angle between man and car is 90 degrees plus 30 degrees. How much? 120 degrees. How much is the angle between man and car? 120 degrees. Next problem given is angle between car and bus. Angle between car and bus. Car is here, bus is here. Now separately draw this angle between car and bus. So bus is making an angle of 60 degrees with southwest. Here the angle is 60 degrees. So find out the angle between car and the bus. This is car. This is bus. Now the angle between car and bus is car and bus. So here 30 degrees, total 90 degrees here, 30 degrees, 90 minus 30, 60 degrees. So angle between car and man is this one, 60 degrees plus 60 degrees. Angle between car and bus is 120 degrees. Next, C is angle between bus and man. Bus and man. Angle between bus and man. So bus is here, man is in this direction. So the axis is here, bus is here. The angle from here to here is 60 degrees. So remaining this angle is 30 degrees. This angle is, these two are perpendicular to each other, 90. So the angle between bus and man is how much? 30 plus 90. 30 plus 90. 120 degrees. So like this we can calculate the angle between vectors. So let us discuss some important points. Resolution of vectors into components in 2 and 3 dimensions. So these are x and y axis. A vector r bar is there. A point vector OP. It is represented with r bar. A vector r bar is resolved into two components in x direction as rx, in y direction as ry. These two vectors are perpendicular to each other. Yes or no? Yes. So in horizontal direction we represent this rx as r cos theta. Rx as r cos theta. In vertical component of this vector r bar is ry, that is represented as r sin theta. That is represented as r sin theta. So here the vector is OA in x direction, OB in y direction. So OA is equal to BP. OA is equal to BP. So OA is equal to BP is equal to Rx. Like this, OB is parallel to AP. OB is parallel to AP. So this is Ry. This is Rx. This is Rx. So this is horizontal component of vector. Is horizontal component x direction. Is vertical. Is vertical component of vector. So the resultant vector r bar is in x-axis we represent with this as rx. I cap represents this is x direction. So ry j cap. Suppose we take this point vector in 3 dimensions. We represent this as rz k cap. rz k cap annattu. rz k cap. Now magnitude of this r bar is, this is the symbol of magnitude, root over rx square plus ry square, rx square plus ry square. Next one is the point vector r bar makes an angle theta with the x-axis. So that angle theta is tan theta is equal to opposite side by adjacent side. Opposite side is ry, adjacent side is rx. So angle theta is tan inverse of ry by rx. Theta is equal to tan inverse of ry by rx. So if a vector is a point vector r bar is represented in two directions, in x and y directions. These x and y coordinates are mutually perpendicular to each other. So the vector r bar in x direction is written as the component rx. Rx means r cos theta. OA is parallel to BP. So OA is Rx, BP is also Rx. Next, in vertical components, that means in y direction, the vector is resolved as Ry. Ry is nothing but r sine theta. OB is parallel to AP. So that is Ry. So the resultant vector r bar can be written as rxi cap plus ryj cap. We represent this in 3 dimensions. We add rz k cap. So magnitude of this vector r bar is root over rx square plus ry square. How much is this vector makes an angle with the x component? How much it makes angle? Suppose that we take that angle theta. Tan theta is opposite side by adjacent side. That is ry by rx. The value of theta is tan inverse of ry by rx. Next one is a vector is there, x-axis, y, here is negative x, here is negative y-axis. Suppose that a bar is a vector that is in first quadrant. We call this as first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. So how can you write this vector in first quadrant? A bar is in first quadrant. Both x coordinate and y coordinate are positive. So we write it as ax I cap plus ay ky j cap. So vector b bar is there in second quadrant. See this, in second quadrant b is in second quadrant, y is positive, x is negative. So we write this b bar as minus bx I cap plus by j cap. So another vector c bar is there. This is third quadrant. In third quadrant, x is negative, y is negative. So we write this vector c bar as minus cxi cap minus cy j cap. So another vector d bar, this is in fourth quadrant. In fourth quadrant, y is negative, x coordinate is positive. So write this as d bar is equal to x is positive, dx I cap minus dy j cap. Like this, can write the vectors in four coordinates. In first coordinate, both x coordinate and y coordinate positive. In second coordinate, x is negative, y is positive. In third coordinate, both x coordinate, third quadrant, both x coordinate, x and y component both are negative. In fourth quadrant, x component is positive, y component is negative. So can write like this. This is important notation in writing vectors in different quadrants. Next one is a vector in space is represented with a point vector, with a point vector of, this is x-axis, this is y-axis, this is z-axis. So this vector r bar makes an angle of alpha with the x-axis, beta with the y-axis, gamma with the z-axis. So here we represent the vector in three coordinates, x, y and z. So we write this as r bar is equal to rx I cap plus ry j cap plus rz k cap. This vector makes an angle of alpha, beta, gamma angles with the x, y and z axis. So we write this as from this cos alpha is equal to adjacent side. We read this component here, Rx, here Ry, here Rz. So cos alpha is equal to adjacent side by hypotenuse. So Rx by modulus of R bar, like this. Cos beta is equal to Ry by modulus of R bar. Next, cos gamma is equal to Rz by modulus of R bar. We call this cos alpha, cos beta, cos gamma as direction cosines. So the sum of these cos values are 1 square beta plus cos square gamma is equal to 1. So L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Keep like this. L square M square plus N square is equal to 1. On simplification we get sin square alpha plus sin square beta plus sin square gamma is equal to 2. How we get this? Cos square alpha is equal to 1 minus sin square alpha. ఈ వాల్యూస్ సబ్స్టిట్యూషన్ చేస్తే మనకి sin square alpha, sin square beta, sin square gamma వాల్యూ వచ్చేసి 2 అవుతుంది అన్నమాట. So these are all some important notations. Next one is, how can you do vector addition? R bar is a sum of two vectors. Sum of A bar and B bar. A bar is equal to Ax I cap plus Ay j cap. B bar is equal to Bx I cap plus By j cap. So R bar is equal to A bar plus B bar is equal to, మనం ఎలా యాడ్ చేయాలి? I కాంపోనెంట్స్ని నెక్స్ట్ j కాంపోనెంట్స్ని యాడ్ చేసుకోవాలి. Ax plus Bx I cap plus Ay plus By j cap. like this. Add the vectors. We can also subtract the vectors like this. Suppose R bar is equal to A bar minus B bar. And then just to AX minus BX. AX minus BX I cap. Next, plus AY minus BY J cap. Like this, we can subtract the vectors. These are all very important notations for doing the problems. Remember all these notations. And practice all this. Like this channel, comment it, share it to others and subscribe this channel. Okay, thank you. We will meet in next time with a more valuable videos. Our next class is exercises on these notations.